Time is the indefinite continued progress of existence and events that occur in apparently irreversible succession from the past through the present to the future. Time is a component quantity of various measurements used to sequence events, to compare the duration of events or the intervals between them, and to quantify rates of change of quantities in material reality or in the conscious experience. Time is often referred to as a fourth dimension along with three spatial dimensions. Time has long been an important subject of study in religion, philosophy, and science, but defining it in a manner applicable to all fields without circularity has consistently eluded scholars. Nevertheless, diverse fields such as business, industry, sports, the sciences, and the performing arts all incorporate some notion of time into their respective measuring systems. Two contrasting viewpoints on time divide prominent philosophers. One view is that time is part of the fundamental structure of the universe, a dimension independent of events in which events occur in sequence. Isaac Newton subscribed to this realist view, and hence it is sometimes referred to as Newtonian time. Time in physics is unambiguously operationally defined as what a clock reads. Time is one of the seven fundamental physical quantities in both the International System of Units and International System of Quantities. Time is used to define other quantities such as velocity, so defining time in terms of such quantities would result in circularity of definition. An operational definition of time wherein one says that observing a certain number of repetitions of one or another standard cyclical event, such as the passage of a free swinging pendulum, constitutes one standard unit, such as the second, is highly useful in the conduct of both advanced experiments and everyday affairs of life. The operational definition leaves aside the question whether there is something called time, apart from the counting activity just mentioned, that flows and that can be measured. Investigations of a single continuum called space-time bring questions about space into questions about time, questions that have their roots in the works of early students of natural philosophy. Temporal measurement has occupied scientists and technologists and was a prime motivation in navigation and astronomy. Periodic events and periodic motion have long served as standards for units of time. Examples include the apparent motion of the sun across the sky, the phases of the moon, the swinging of a pendulum, and the beat of a heart. Currently, the international unit of time, the second, is defined by measuring the electronic transition frequency of calcium atoms. Time is also of significant social importance, having economic value. Time is money, as well as personal value due to an awareness of the limited time in each day and in human lifespans. There are many systems for determining what time it is, including the Global Positioning System, other satellite systems, Coordinated Universal Time, and Mean Solar Time. In general, the numbers obtained from different time systems differ from one another. Measurement. Generally speaking, methods of temporal measurement or chronometry take two distinct forms: the calendar, a mathematical tool for organizing intervals of time, and the clock, a physical mechanism that counts the passage of time. The second is a clock, a physical mechanism that indicates the passage of time consulted for periods less than a day. The combined measurement marks a specific moment in time from a reference point or epoch. Time is one of fundamental physical quantities, both in the terrestrial system units and international system of quantities. History of the calendar. Artifacts from the Paleolithic suggest that the moon was used to reckon time as early as 6,000 years ago. Lunar calendars were among the first to appear, with year of either 12 or 13 lunar months, either 354 or 384 days. Without intercalation to add days or months to some years, seasons quickly drift in a calendar based solely on 12 lunar months. Lunisolar calendars have a 13th month added to some years to make up for the difference between a full year, now known to be about 365.24 days, and a year of just 12 lunar months. The numbers 12 and 13 came to feature prominently in many cultures, at least partly due to this relationship of months to years. One early forms of calendars originated in Mesoamerica, particularly in ancient Mayan civilization, in which they developed the Maya calendar, consisting of multiple interrelated calendars. These calendars were religiously and astronomically based. The Hab calendar was 18 months in a year and 20 days in a month, plus 5 epogomenal days at the end of the year. In conjunction, the Maya also used a 260-day sacred calendar called the Tzolk'in. The reforms of Julius Caesar in 45 BC put the Roman world on a solar calendar. This Julian calendar was faulty in that its intercalation still allowed the astronomical solstice and equinoxes to advance against it by about 11 minutes per year. Pope Gregory XIII introduced the correction in 1582. The Gregorian calendar was only slowly adopted by different nations over a period of centuries, but it is now by far the most commonly used calendar around the world. During the French Revolution, a new clock and calendar were invented as part of the dechristianization of France and to create a more rational system in order to replace the Gregorian calendar. The French Republican calendar's days consisted of 10 hours of 100 minutes of 100 seconds, which marked a deviation from the base 12 duodecimal system used in many other devices by many cultures. The system was abolished in 1806.